This is the third and final video in the Test 2 review, and it covers material on fundamental trig identities and verifying trig identities. In our first problem, we're told that sine theta equals 2/3 when theta is in quadrant 2, and we're asked to evaluate the remaining 5 trig functions of theta. So first, remember that if theta is in quadrant 2, then the only value of theta that should be positive would be sine. So we're going to start off by evaluating cosine of theta. So in order to do this, we have to remember that sine squared theta plus cosine squared theta equals 1. So we're going to take our value for sine theta and plug it in. So 2/3 squared plus cosine squared theta equals 1. Now we can solve for cosine, so 4/9 plus cosine squared theta equals 1. Cosine squared theta equals 1 minus 4/9, which is 5/9. So cosine theta would be positive or negative root 5 over 3. However, since we know that we're in quadrant 2, we can go ahead and say this is going to be negative root 5 over 3. So cosine of theta is equal to negative root 5 over 3. Next, we're going to evaluate tangent of theta. So it's important to remember that tangent theta equals sine theta over cosine theta. So we know what sine theta is and we know what cosine theta is, so we can just plug these values in. So we're going to have 2/3 divided by negative root 5 over 3. So if we work that out, that's going to be the same as 2/3 times negative 3 over root 5. So you'd have negative 6 over 3 root 5. However, we have to rationalize our denominator, so we're going to multiply by root 5 over 5. And once we do that, we're going to have negative 6 root 5 over 15. So that is our value for tangent of theta. Negative 6 root 5 over 15. Next, we can work on cotangent of theta. So we know that cotangent theta is equal to cosine theta over sine theta. So again, similar with tangent, we can just plug in the values that we already have. So we'll have negative root 5 over 3 divided by 2/3, and that's going to be the same as saying negative root 5 over 3 times 3/2. And if we multiply that, we'll have negative 3 root 5 over 6 as our value for cotangent. So negative 3 root 5 over 6. Next, we're going to evaluate secant of theta. So remember that secant of theta is actually equal to 1 over cosine theta. So again, since we know our value for cosine theta, we can just plug it in and solve. So secant theta is 1 over negative root 5 over 3, which would be negative 3 over root 5. And again, we have to rationalize by multiplying by the square root of 5 over the square root of 5. And we're going to have negative 3 root 5 over 5 as our value for secant theta. So let's go ahead and write that in. Negative 3 root 5 over 5. And finally, we're going to solve for cosecant theta. So remember that cosecant of theta is equal to 1 over sine theta. So we're just going to plug it in. 1 over 2/3 is equal to 3/2. So cosecant theta is 3/2. So remember, if you're given a value of one trig function and given the quadrant, you should be able to go ahead and use some of your fundamental trig identities to solve the exact value for your remaining 5 trig functions. In this problem, we're asked to simplify tangent of x divided by secant of x, and we can do that using some of our identities. So the first thing we're going to do is rewrite this. So tangent of x is equal to sine x over cosine x, and secant of x is equal to 1 over cosine of x. So this can be written as sine x over cosine x times cosine x over 1. So that's going to equal sine x cosine x over cosine of x, and we have these cosines that can cancel, and so our final answer for our simplification would just be sine x. So tangent of x over secant of x is equal to sine x. Here we're asked to write sine of x in terms of cosine of x. So again, in this one, we're going to look at the fact that sine squared x plus cosine squared x equals 1. So we want to basically solve for sine and then have cosine on the other side of our equation. So what we're going to do is we can subtract cosine squared x from both sides. So we'll have sine squared x equals 1 minus cosine squared x, and then we need to take the square root to solve for sine. So we'd have sine x equals positive or negative square root of 1 minus cosine squared x. So it's important to keep in mind right here this positive or negative. That's going to depend on which quadrant you're in. Depends on quadrant. So if you're solving a problem and you're told that theta is in quadrant 1 or 3 or 4, that's going to help you to determine whether or not that should be a positive or a negative. In this problem, we're asked to solve cotangent of x times the quantity tangent of x minus secant x. So the first thing we can do is distribute cotangent. So we would have cotangent x tangent x minus cotangent x secant x. So from there we can sort of expand these or rewrite them using identities. So we would have cosine of x over sine of x, because that is cotangent of x, times sine of x over cosine of x, right, because that goes with our tangent of x, minus cosine x over sine x times 1 over cosine of x. So clearly here our sines and cosines are going to cancel. So we're going to have 1 minus cosine x over sine x cosine x. And again, we can cancel these cosines. So as our final answer, we're almost there, we have 1 minus 1 over sine x, which can be written as 1 minus cosecant of x. So we'll write that up here as our final answer. 1 minus cosecant x. In this problem, we're asked to factor sine cubed x minus cosine cubed x and simplify. So the first thing that we can notice about this problem is that sine cubed x minus cosine cubed x can also be written as sine of x cubed minus cosine of x cubed. Now when it's in this form, it's really easy to spot that this is actually a difference of cubes. So remember, our formula for difference of cubes is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So we can use this to factor our sine cubed x minus cosine cubed x, where we can consider sine x as our a and cosine x as our b. So once we factor this, it's going to look like sine x minus cosine x, so that's our a minus b part, times sine squared x plus sine x cosine x plus cosine squared x. That is our second part of the difference of cubes. So we're almost done, but the one thing that's important to notice is that we have a sine squared x and a cosine squared x, and we know that sine squared x plus cosine squared x equals 1. So we can simplify this one step further to sine x minus cosine x times 1 plus sine x cosine x, and that would be our final factored and simplified answer. In this problem, we're asked to complete an identity for cosine to the fourth of x minus sine fourth of x. So the first thing that we can do here is notice, similar to our first problem, that this can be rewritten, or similar to the previous problem. So we could write this as cosine squared x squared minus sine squared x squared. And when it's in that form, we can notice that this is a difference of squares. So with a difference of squares, that can be factored into a minus b times a plus b, where we can treat our cosine as a and our sine as b. So were we to do that, we would now have cosine squared x minus sine squared x times cosine squared x plus sine squared x. So we know that this right here is just our Pythagorean identity, so that's going to be equal to 1. So now we have cosine squared x minus sine squared x. So we can simplify this one step further. So remembering that sine squared x plus cosine squared x equals 1, we also know that sine squared x equals 1 minus cosine squared x. So we can plug that in and have cosine squared x minus 1 minus cosine squared x. And making sure that we keep track of our negatives and subtraction, we're going to end up with 2 cosine squared x minus 1 as our final answer. So when we're working with trig identities, it's obviously very important to remember that sine squared x plus cosine squared x equals 1. And it's also important to remember that a good first step to take would be to write things in terms of sine and cosine. So we would take cotangent and we can write that as sine over cosine. Cotangent we can write as cosine over sine. Cosecant would be 1 over sine. And secant is our 1 over cosine. You also want to remember to look for difference of cubes and squares, as that can be helpful in factoring or simplifying. So this is the final video for the test 2 review, but you can find additional practice problems to work through on the online test review. So if you feel like you need some extra practice, you can just go take a look there.